Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject of physics, class 10, chapter number 11, human eye and colorful world. Topics, case-based questions about 11.3, refraction through a glass prism, 11.4, dispersion of white light by a glass prism, 11.5, atmospheric refraction, 11.6, scattering of light. Before going to see the topic, you have to know the basic concept about refraction through a glass prism. Look at this image. This is a glass prism. When the light incident on the glass prism, this ray is called incident ray. This is a point of incidence. We have to draw the normal line. And this is air medium and this is a glass medium. The air medium act as a rarer medium and the glass medium act as a denser medium. So when the light travel from a rarer medium to denser medium, the refraction taken place. So this is a refractor ray. Here this is a glass and this is a air medium. So when the light travel from glass medium to air medium, again the refraction taken place, but here we can say that this ray is called emergent ray. So there are the three type of ray. One is incident ray, a refractor ray and emergent ray. The angle between the normal line and incident ray is called angle of incidence I. The angle between the normal line and refractor ray is called angle of refraction. The angle between the normal line and emergent ray is called angle of emergence. So there are the three type of angle. One is angle of incidence, the next one angle of refraction, the third one angle of emergence. If I draw the incident ray at the back, this is a very important, please listen carefully. If I draw the incident ray at back, this is an incident ray. The same if I draw the emergent ray at back, they meet at one point and makes a angle. This angle is called angle of deviation. Angle of deviation. And here the two plane surfaces or make angle. This angle is called angle of prism. So there are the five angles present in the refraction through a glass prism. One is angle of incidence, angle of refraction, angle of emergence, angle of deviation and angle of prism. So this is a basic concept about refraction through a glass prism. Now read the following question and answer any four. A prism is a transparent refracting medium bounded by two plane surfaces inclined to each other at a certain angle. So look here, this is a prism. It is a prism these two surfaces are a transparent medium bounded by some angle. This angle is called angle of prism. The refraction of light through a prism follows the law of refraction. In the prism, refraction takes place on its refracting surface. It means when the light enters the prism and when the light leaves the prism. You know that the prism is made up of refracting medium. So when the light incident on the refracting medium, the refraction taken place. The same also when the light leave from the medium, the refraction takes place. The refraction through a prism is shown. So this is a refraction of the prism they shown in the image. Here A is the angle of prism. So this is the angle of prism. I is the angle of incidence. See, this is the angle of incidence. The face AB. So the I placed in the face AB. And E is the angle of emergence. See, E is the angle of emergence at the other face AC. So it was placed in the face AC. The incident ray suffers a deviation or bending through an angle delta due to the refraction through a prism. So see, this is an incident ray suffers a deviation. This is a incident ray suffers a deviation or bending through an angle delta. This is angle of deviation. This angle is called angle of deviation. So the emergent ray and the incident ray meet at one point and it makes some angle. That angle is called angle of deviation. So the angle of incidence plus angle of emergence is equal to angle of deviation plus angle of prism. You have to answer the first question. The angle between the two refracting surfaces of a prism is called. The angle between two refracting surfaces. These are the two refracting surfaces. So the angle between the two refracting surfaces is called angle of prism. So the option A is the correct answer. The angle between the two refracting surfaces of a prism is called angle of prism. The angle between the incident ray and the emergent ray is called. See, this is the incident ray and this is the emergent ray. So the angle between the incident ray and emergent ray is called angle of deviation. The correct answer is angle of deviation. The third question, when a ray is refracted through a prism, then see, this is an incident ray, air medium, and this is a glass medium. Air medium acts as a rarer medium and glass medium acts as a denser medium. So when the light travels from rare medium to denser medium, it bends towards a normal. That means I is always greater than the R. The angle of incidence is always greater than the R. This concept we already learnt in the chapter number 10. How? If you take rarer medium and denser medium, this is an incident light, this is a normal line. So when the light travels from rarer medium to denser medium, it bends towards the normal. So comparing to the angle of incidence, the angle of refraction is always less. So when a ray is refracted through a prism, then see, option D is the correct answer. The angle of incidence is always greater than angle of refraction because the light travels from rarer medium to denser medium. The fourth question, The angle of deviation depends on. See, this is a angle of deviation. This angle of deviation depends on the angle of incidence and the refracting refractive index of the prism. So it depends on the two factor. One is the refractive index of the prism and another one is angle of incidence. So option C is the correct answer. Both A and B. The rectangular surface of a prism are known as. Look at this image. This is a prism. It consisting of three rectangular faces and two triangular faces. The first rectangular face, the next rectangular face, and then another one is that side, and two triangular face. So the rectangular surface of a prisms are known as reflecting surface, dispersing surface, or refracting surface. None of these. Here the rectangular surface are acting as a refracting surface. So when the light fall on this, surfaces, the refraction taken place. So option C is the correct answer. The next question. Read the following and answer any 4 questions from 2 to 5. 1 to 5. When white light is incident on one refracting surface of the prism, if you take a prism, the prism consisting of two refracting surfaces. So when the light fall on one refracting surface, the light split up into constituent colors. So see, it is clearly shown here. When the light fall on the one refracting surface of the prism, the light splits up into constituent colors like violet, indigo, blue, green, yellow, orange, red. The process of splitting of white light into its 7 constituent colors are called dispersion. So here the white light are split into 7 colors. This is called dispersion. When the dispersed white light is made to fall on a screen, we get the band of 7 colors called spectrum. So the 7 colors are called spectrum. Spectrum of white light. Red color bends the least on passing through the prism, and violet color bend through maximum angle passing through the prism. So see the angle. This is a prism. When the light fall on, the refraction taken place. The red bend least and the violet bend most. See, this is the angle of violet and this is angle of red. So listen the question. The splitting of white light can be done by option A lens, option B prism, option C mirror, option D none of these. Look at this image. Here we are getting the splitting of white light by the prism. So option B is the correct answer. Which property of light is used by prism to form a spectrum? Reflection, refraction, dispersion, scattering. The band of 7 colors are called spectrum. This spectrum is obtained by the process of dispersion. So option C is the correct answer. In third question, which of the following dispersion is correct? The white light split it into 7 colors, the red, blue. So you have to write WebGR. You have to write the WebGR. The red is at the top. So this is wrong because the blue is at the top. This is also wrong. And this is also wrong. And the blue at the down. Okay. The red is at the top, blue at the bottom. So option A is the correct answer. The next question. When a red light passes through a prism, it C. When the white light passes through the prism, it is split into 7 colors from red to violet. But when we pass the red color to the prism, the red emerges from the prism. It not split into 7 colors. The same as if you change the blue color only will come out. The white light only split into 7 colors. So when a red light passes through a prism, it option A will not split. Option B will split into 7 colors. Option C will split into white color. Option D will split into many different colors. So option A is the correct answer, will not split. The red light pass means the red light also emergent. The blue light pass means the blue also emergent. But when the white light pass, it dispersed into 7 colors. The spectrum produced by the white light by a prism is called impure spectrum. What is the difference between the pure spectrum and impure spectrum? When we get the spectrum of colors sharply on the screen, that spectrum are called pure spectrum. But the prism always give impure spectrum. That means the colors are overlapping. The red and orange are overlapping with each other. That type of spectrums are called impure spectrum. The prism always give impure spectrum. The next question. Read the following and answer any 4 questions from 3, 1 to 5. Light of all color travel at the same speed in vacuum for all wavelengths. If you take a visible light, it consisting of the 7 colors. The 7 colors have different wavelength. See here, the red has the longest wavelength and violet has the shortest wavelength. So when the light travel in the vacuum, the speed of all the colors for all the wavelength or the speed of all the colors are same. In vacuum, the speed of all color lights are same. But in any transparent medium, that means if you take a glass prism, it is a transparent medium. The light of different colors travel with different speed for different wavelength. That means that the refractive index of a particular medium is different for different wavelength. So when the light travel into the medium, it travel at a different speed and it makes a different angle because the refractive index of the medium is different. If you take a vacuum, the refractive index is different from the medium glass. So according to the medium, the refractive index of the medium, the different colors travel with different speed for a different wavelength. As there is a difference in their speed, the light of different colors bend through different angles. You know that in a speed difference we know that the red makes a least deviation and violet makes a most deviation due to the different wavelength and different speed. The speed of the violet color is maximum, not maximum. The speed of violet color is minimum. They given wrongly. The speed of violet color is minimum and the speed of red color is maximum in class. So the red deviates least and the violet color deviates most. Hence, higher the wavelength of color light, smaller the refractive index and less is the bending of light. I will explain you. Please listen. Understand this paragraph. Light of all color, this is a light of all color, travel at the same speed in vacuum. They travel at the same speed in vacuum. But when it enter into the medium, that means a glass medium or any other medium, the speed of the light are different according to the different wavelength. And here the violet color is, the speed of violet is minimum and the speed of red is maximum. And it makes, the red color makes a least angle and violet makes a most angle, most deviation angle. Listen the question. Which of the following statement is correct regarding the propagation of light of different colors of white light in air? Red light moves fast. Blue light moves faster than green light. All the colors of white light move with the same speed. Yellow light moves with the mean speed as that of the red and the violet. Which of the following statement is correct regarding the propagation of different color of white light in air? If you take air and vacuum, the speed of the light of all the colors are same. So, all the colors of the white light move with the same speed is the correct answer. In air and vacuum, all the color of the light moves with the same speed. In question number 2, which of the following is the correct order of wavelength? See, the red is the maximum wavelength and violet is the minimum wavelength. They given the order. You have to find out which order is the correct. They given first red more, then green, okay, then yellow. No, this is wrong. This is wrong. The second one, red, okay, violet, green. So this is also wrong, in not proper order. The third one, in third one, yellow first, okay, then green, okay, then violet. So these are the increasing order. So option C is the correct answer. We will check option D also. Red, yellow, orange. This is the wrong order. So option C is the correct order. Which of the following is the correct order of the wavelength? Yellow, green, violet. The third one, which of the following is the correct order of speed in light in glass? The red have maximum speed and violet have minimum speed because the speed is directly proportional to the wavelength. Please note this point. The speed is directly proportional to the wavelength. If the wavelength is high, more means the speed also more. So here the red light has the longest wavelength. So the speed of the red light is maximum. And the wavelength of the violet is minimum. So the speed also minimum. You have to find the correct order, the speed of light in a class. First they given red, then green, then blue. Okay, this may be correct. We will check the B option also. Blue, blue, green, red. This is wrong because the red move fast. The next one, violet. This is also wrong because the violet has the minimum speed. The next one, green, red. Comparing to the green, the red has the more wavelength. So red first, green second, and blue. Comparing to the green, the red has longest wavelength. Comparing to blue, the green have longest wavelength. So option A is the correct answer. Please you note this point. The wavelength is directly proportional to the speed. If maximum wavelength means the speed of the light also maximum. So minimum wavelength means the speed of the light also minimum. The next question, which color which has maximum frequency? See, the wavelength is inversely proportional to the frequency. That means this is also important point. Note down, the wavelength is inversely proportional to the frequency. That means the wavelength more means the frequency minimum. The wavelength minimum means the frequency more. So here they are asked the maximum frequency. Which light have the minimum wavelength? Red, violet, blue, green. The violet has the minimum wavelength. So it has a maximum frequency. Which of the following is the correct order of angle of deviation? The angle of deviation is more for, see, this is angle of deviation is a more for violet light, less for red light. So they given the first one, the red has the maximum. So this is wrong. And second one, they given blue, blue, yellow, orange. So this may be correct. We will check for the option C and D. Orange, orange, orange maximum, then red. So this is wrong, not in a proper order. The next one, blue, green, violet. This is also not proper order. So which one is the correct one? Blue, yellow, orange. So comparing to the yellow, blue have the maximum deviation, and comparing to the orange, yellow have the maximum deviation. So option B is the correct answer. Dear students, I hope you understood. If you have any doubt, you can ask through the teachment. In teachment session, again I will teach through the live. You have to watch the video and take some notes and ask some doubts through teachment session. Thank you for watching.